Hello, everyone. Good morning. This morning, I'm going to talk about one of the mainstream cost accounting methods called job order costing. Along with process costing, job order costing has dominated the managerial accounting scene for decades. What is job order costing? Job order costing is a costing method that accumulates all costs relevant to an identifiable job. Remember, relevant to a defined, very well-defined job. So you have to have a job that's well-defined, and then your job is to accumulate, is to put together all costs relevant to that particular job. So we have some examples here. When job order costing is applied, it's usually applied in companies like these. You can see Boeing, for example, Bechtel Construction, Warner Brothers for movies. So you have to have a job versus process costing. The other mainstream cost accounting method that I mentioned was process costing. And process costing is applied where similar products, similar like medicines, like Coca-Cola bottles, like soap bars, like iPhones or muesli bars. So that is where we use process costing. Let me show you a couple of those process costing products. You can see. So this would be an example of a process costing product. And so is this. This phone is process costing, where a uniform product, a uniform item will be produced in thousands, in dozens, hundreds. So like a biscuit factory, pharmaceutical industry, bread factory, those places are the places where we apply process costing. Our next chapter, chapter 3 of Garrison textbook, is on process costing, but today's discussion is based on chapter 2, job order costing. All right. So let's come back to these examples. As I said, Boeing, for example, Boeing or Airbus, they manufacture aircrafts made to order. So if Qatar Airways, for example, or Emirates or British Airways or American Airlines, United, so you place an order for 40, say 747 aircrafts, 40 Dreamliners, 747, or A380, Airbus 380, the top of the range, or any other model. So you asked for 40 units of a particular specification planes, and their job is to manufacture those 40 or 5 or 1. So that's when they apply job costing. So job costing can be applied to a small job like mowing your lawn or painting your wall, or even making tea. So making a cup of tea is a job. I can apply job order costing here because it's a job, and it's different from any other job that I do. So washing your cleaning, doing the dishes, mowing the lawn, or even vacuuming the floor. These are all examples of job costing. You consider them as individual identifiable jobs. Constructing a bridge, for example, doing the Bay Bridge, or repairing a wall, or even repairing a bridge, or building homes. These are building a stadium, building roads, bridges. These are all examples of job order costing. All right. So in job order costing, let's see how it works. This is how it works. You can see we have materials, direct material, and you can see direct material cost goes to jobs 1, 2, and 3. Material goes to all the jobs, and labor goes to all the jobs too. So after material and labor, after these two, what's left? We're left with overhead. So let's see how we apply overhead. Now, manufacturing overhead is one of the most treacherous elements of cost. I call it very treacherous, very clever, because it can include everything, anything and everything. Anything that is not directly traceable, directly assignable to a particular job or to a particular product is overhead. By definition, overhead includes supervisory costs, anything that's over our head, like the benefits of that service is enjoyed by all the products being manufactured on the floor, or all the jobs that we are currently engaged in. So let's say we have a construction firm and we have 3 construction projects going on right now, and we have 1 management. We have 1 design department, 1 marketing department, 1 accounting department, 1, say, post-sale customer feedback or customer satisfaction department, customer relations department. So all those departments, or even a cafeteria, even a swimming pool, or a tennis court. So all these, you can see all these services are consumed in different proportions or maybe in equal proportions by all the projects that you have at the same time. Now, if you have 1, 2, or 3 construction projects going on at the same time, they all have their identifiable amount of materials and labor. That's very easy because we know how much material, how much bricks and weatherboards and roofing materials are shipped to which project or which construction site. But what we don't know is how much of our managerial services, how much of our supervisory services or leadership services are being enjoyed or consumed by those individual job sites. So that's why allocation of overhead is an important managerial accounting task. And the more accurate you are, the better, the more efficient pricing and costing system you have in place. The less efficient you have, the more tension between jobs or among jobs or among departments. Anyway, so we consider it a 4-step process, you can see here. So this is based on the discussions in the chapter. You can see predetermined overhead rate is equal to estimated total manufacturing overhead cost. So estimated total cost divided by estimated total number of allocation base. So that allocation base could be hours, machine hours, or labor hours, or even number of units, or even number of projects or number of sites. So there are many ways you can define this allocation basis. But what's important is that that allocation basis should be a fair one, should be one that represents the actual resources consumed by that particular unit or that particular job. All right, so the numerator here is estimated. I'm not sure if you can say it clearly. Estimated total manufacturing overhead cost. So that's the estimated total. So let's say the budgeted total cost, and divided by the estimated total amount of allocation base. All right, so we have a 4-step process. First, it requires us to estimate the total amount of the allocation base. So the allocation base could be total number of hours, number of labor hours, number of machine hours, or number of units. So we have to estimate that, like how many hours we're going to have, we're going to be working during the year. So let's say we have 10,000 hours. That to do all the jobs, we have 1,000 people, and each of them work like 10 hours a year, or 10 hours a day, or say 8 hours a day. So in any possible way, you find out how many hours your machine is going to work, or how many hours your labor is going to work throughout the year. And then estimate the total fixed manufacturing overhead cost. These are also estimated fixed manufacturing overhead, which is fixed, like doesn't depend on any volume or any number of hours. Fixed overhead like managerial salary, like CEO pay, like headquarter depreciation, all the equipment depreciation, and rent, salaries, and holiday pay, things that are fixed. Number 2, you also estimate the total manufacturing overhead cost using total manufacturing overhead plus the variable one. So in number 2, you estimated total fixed manufacturing overhead for the coming period, and also the variable manufacturing overhead rate. So what we mean here in step number 2 is that your estimated total fixed is, say, $100,000 or a couple of $100,000. So that is easier. You know, we know what are our fixed costs, mostly non-discretionary or mostly committed fixed costs, and then, or all committed costs. And then we have to also estimate the variable manufacturing overhead per machine hour or per labor hour or per allocation base. So once we have that, we now can, we are in a position to estimate the total manufacturing overhead using a linear equation, mx plus c or a plus bx, which I'm showing you here. You can see this is going to be the equation, a plus bx, where a is the fixed manufacturing overhead, b is the beta coefficient, like the variable manufacturing overhead rate or variable manufacturing overhead per hour. It's very blurred. I don't think you can see it right here. So B is the variable manufacturing overhead rate per unit of the allocation base. So if that base is, say, machine hours or labor hour, then per hour, what is the per hour variable manufacturing overhead rate? And then number X, or the third one, is the variable number of units of the allocation base that you're going to use. So if we have a plan to use say 10,000 hours and our fixed was $200,000, variable is say $2. So the total estimated manufacturing overhead is going to be $200,000 plus 2 times 10,000. $200,000 plus 2 times 10,000. So let me show you. So let's say, so A is equal to $200,000 plus $2 times 10,000. So that gives us $220,000. So this is what is going to be your total estimated manufacturing overhead. You can see there's the fixed component. 200,000 is the fixed component, and then $2 times 10,000. So once you have that, well, I actually had an example here. At the bottom of it, you can see there's our example. So fixed manufacturing overhead, which I had $200,000, and the variable overhead rate is $2, and the number of hours was 500,000. Estimated number of allocation base, which is machine hours. So that gives us total manufacturing total estimated manufacturing cost of $1.7 million. You can see that's $500,000, and here is $100,000, 2 times 500. So the total is $1.7 million, and if you divide it by the number of hours, which is 300, you'd get $5.67 per hour. So that's how you estimate the hourly rate, predetermined hourly rate. So what do you have here? $200,000 is the fixed manufacturing overhead plus $300,000 times $5. $5 is the hourly rate. So 5 times 300 is 1,500 plus 200 makes it 1,700. 1,700,000 divided by $300,000 is $5.67. So this is how we estimate the predetermined manufacturing overhead. Once we have that predetermined overhead rate, then we simply apply that to the particular job. So the job could be a small job like taking only 10 hours, or it could be a big job taking 1,000 hours. So if it takes only 10 hours, you put your material plus labor plus 10 times $5.67. So that gives you the job cost. So this is how it works. Let me show you an example here. So please take a look at this. Here we have a job cost sheet. Direct material is $200. Direct labor, 10 hours at $15 each, which should be $150, but I wrote it as 300 to see if you're paying attention. So this is, here's $200 of direct material, $300 of labor. Let's say $30. Let's make pay the labor a little more than $15. So let's pay them $30 an hour. So that gives us $300 of labor plus the overhead. So how much manufacturing overhead we have to assign here? So I calculated the predetermined overhead rate first. You can see the same formula, estimated total overhead divided by estimated number of hours, estimated labor hours here. So our total estimated cost, overhead cost is say $50,000 divided by 1,000 if that's the planned number of hours that we'd like to work. So that gives us $50 an hour. So sorry, $20,000 by 1,000. So that gives us $20,000 an hour. So at $20,000, $20 an hour, if we pay them for $10, 10 hours, it would be another 200. So that makes it a total of $700 of job cost. Can you see? Direct materials of $200, labor $300, although there's some mistake here. It should be 10 hours at $30 an hour. Plus overhead is $200. So 2 plus 3 plus 2 makes it $700 of total job cost. So to sum up, it is simple. Your job is to assign, to trace and allocate all the costs relevant to the particular job. And by all costs, we mean material. Now we have one type of material. In a real world, it would be hundreds of different types of materials. Imagine a construction project. Imagine the Padma Bridge that we're having in my native country, native Bangladesh now. So there would be tons and thousands of tons of materials. So we add all the materials, and because it's very easily identifiable. And like my tea, I know exactly how much material goes in here, isn't it? And I know how much labor, like in terms of my time, but what I don't know is the contribution of this kitchen and the house and the computers and the lights and the heating and the water taps and kitchen equipment, the fridge. So that is the most challenging part, that how much of the overhead is being consumed by my cup of tea. You see, it could be 5 cents. I hope it's really little, but it also depends on how many cups of tea I make and what different kinds of activities, activities go on in this kitchen or in this house. So the more activities we have, the less and less would be the overhead contribution. That's why large scale, say economies of scale, that when you have huge, a lot of activities going on, when you have diversified operations, a lot of units, and a lot of activities, a lot of customers, then your overhead allocation is much more efficient, because the overhead amount gets smaller and smaller and smaller. If you have less activity, dull business season, then because you're stuck with the same fixed overhead. Overhead is primarily fixed. So fixed cost and overhead are more or less synonymous. Anyway, so that is how the job order costing works. Job order costing is applied to businesses where jobs are easily distinguishable, like they're not uniform. If there is a huge and high amount of uniformity between or among jobs, then we are much better off applying the process costing. Like in garments factories, where you make 10,000 or thousands of units of the same denim, same jeans, same shirt, same trousers, or same like in a biscuit factory or in a pharmaceutical factory. I have an example for us to do, which is from the textbook, the Foundational 15, I call it, they call it. It's from page number 79. Please see. Yeah, it's visible now. So this is the information. You can see estimated. Estimated machine hours consumed by the two departments, molding and, I think we're better off. No, it's not bright anymore, not sharp. I don't think you can read it. So that's the Foundational 15, page number 17, Garrison et al. Textbook. Yes, we got it now. So estimated machine hours, you can see there are two departments here. One is molding, another is fabrication. In molding department, we have 2,500 hours. In fabrication, we have 15. So the total number of hours is 4,000. Then estimated total fixed manufacturing overhead, that is the fixed component, 10 and 15, $10,000 and $15,000, total 25. And then the estimated variable manufacturing overhead per machine hour. Variable is per the allocation base. The allocation base here is machine hours, which is $1.40 for the molding and $2.20 for the fabrication. And then there are two jobs here, jobs P and Q. Direct materials issued to job P is 13, Job Q is $8,000. Direct labor cost, $21,000 and $7,500. The actual machine hours used in molding department was 1,700 hours. In job P was 1,700, and in job Q was 800 hours, and in fabrication department was 600 and 900 for the two jobs. So you have, remember, two departments and two jobs here. So 2 to 4, 2 by 2 matrix. So don't forget there are two jobs, jobs P and Q, and two departments, fabrication and molding. And note down their number of hours. So to review the information given, this is the question. Again, we have two departments, molding and fabrication. Estimated machine hours for the whole period, the whole year, 2,500 and 1,500 hours. So that's 4,000 hours. Estimated total fixed manufacturing overhead, 10 and 15, making it 25. Variable rate, $1.40 and $2.20. Jobs P and Q have their respective materials, labor, and overhead. So overhead is not allocated here. See, these are not in dollar amounts. These are in hours. We have to find out how many dollars. So all you have to do is multiply them by the respective rates. So for molding, for example, molding rate is $1.40. So if molding contributes 1,700 hours here and 800 hours, so we're going to multiply in the solutions, we're going to multiply this 1,700 by $1.40 and this 800 by also $1.40. And again, we're going to do the same for fabrication. 600 hours assigned to job P. So their rate is, hourly rate is $2.20, and 900 hours is assigned to job Q, and we're going to multiply it by the same rate, $2.20. So that's our question. Remember, easy question, and these are the solutions. Our first requirement one was find out the predetermined overhead rate for the molding and the fabrication departments. Predetermined overhead rates. So what do? We need to find out the estimated fixed overhead, estimated variable overhead rate, and multiply it by number of hours. So the equation is going to have $10,000 as fixed. That's our A, plus BX. What is B? Beta is $1.40, and X is 2,500 for the molding department. Can you see? That's our fixed overhead, $10,000. That's the variable overhead rate, $1.40, and we're going to multiply it by 2,500 because that's the estimated number of hours that are going to work in the molding department. And then we have $15,000 of fixed manufacturing overhead or fixed cost in the fabrication department. It's going to be added to the variable rate times the hours. So this is the hourly rate in the fabrication department, $2.20, multiplied by 1,500 hours we're going to work there. So you can see the total manufacturing overhead is going to be $10,000. This is for molding, 10,000, see, plus $1.40 times 2,500. So that gives us a total of $13,500. And for fabrication, it's going to be $15,000 plus 2.2 times 1,500. You can see 15,000 plus 2.2 times 1,500. That gives us $18,300. So this is the total estimated overhead for the molding department and total estimated overhead for the fabrication department. If you now divide this by the hours, like $13,500 by 2,500 hours, you're going to have an hourly rate, which is $5.40. And we're going to do the same for the fabrication department, divide $18,300 by their number of hours. We're going to have an hourly rate of $12.20 for them. So this is the solution to the first requirement. And the first requirement was that determine the overhead, find out the predetermined overhead rate of the two departments, the molding and fabrication departments. All right, now the second, there are 15 requirements. Don't forget, quite a few. So the second requirement is this. Find out the molding department overhead applied to the two jobs. So once we know the rate, application is easy. It's going to be the hourly rate. So the hourly rate for the molding department was $5.40. For the fabrication was $12.20. So for molding, it's going to be 1,700 was their hours. I'm sorry. right? So 1700 times $5.40 goes to job P, and $5.40 times 800 goes to job Q. Simple. So please keep an eye on the question. The question says molding department manufacturing overhead. So focus on molding alone. Molding department's rate was $5.40. But molding department contributed to both the jobs, both P and Q, at the rate of $5.40 an hour. So $5.40 times 1700, that goes to P, and $5.40 times 800 goes to Q. And now we are going to do the same for the fabrication department. So you know what's coming up? Simple. Their hourly rate was $12.20, and their hours was 600. So they contributed 600 hours to project P, job P. So 600 times $12.20, and they contributed, this is by fabrication department I mean, so they contributed 900 hours, and their hourly rate was $12.20. So that's the total. That's the overhead applied. This is excluding material and labor, remember, excluding material and labor. So we just have their overheads. That's requirement 3. Requirement 4 says total manufacturing cost assigned to job P. Must be simple. Total manufacturing cost assigned means it will include material, labor, and overhead. So how much material? Material was $13,000, labor was $21,000, and overhead was $16,500. Remember, where did you get $16,500 from? Here. Total manufacturing assigned to job P. So P had, see, 9,180 from the molding department, and 7,320 from the fabrication department. So the two together, see, I've added them here. This is contribution of the molding department to project P, contribution of the fabrication department to also project P. So the total overhead assigned to job P is 16,500. So if we add the three together, we have the total manufacturing cost of the project. I call project like of job P. But then that leads us to the next requirement is what is the unit cost? Unit production cost. Well, the answer to the previous requirement divided by number of units. So the answer to the previous requirement was $50,500. $50,500 you divided by number of units, which was 20. So that would give you the unit cost. And remember, we're going to do the same for Q by rotation. Now, requirement 6, see what it says. Requirement 6 is total manufacturing cost assigned to job Q. So just repeat the same process that you did for project P or job P. So their materials here was, it is $8,000 to job Q, labor is $7,500, and manufacturing overhead, remember the two, molding and fabrication. Molding's contribution to job Q and fabrication's contribution to job Q. So the two together is 15,300. So if we add the three together, we're going to have $30,800. That's the total cost of job Q. And if you divide it by number of units, you get the unit cost. Job Q had 30 units. So we'd have to divide this total by 30, which we did here. That gives us $1,027. So that's our requirement 6 and 7. Gone. Requirement 8 says, give us the selling price for the two jobs, assuming that the company uses a cost plus pricing. Cost plus pricing means cost plus a particular rate of profit or markup, they call. So markup here is 80%. So please see, selling price of the jobs with a markup percentage of 80%. That was the question. So I said, I wrote this little formula. It says selling price equals cost plus markup. That means cost plus cost times the markup percentage. Because cost is cost, then the amount of markup is based on your cost times the markup percentage. So that means if we take cost as common, that means cost times 1 plus markup. So in our case, it's 80%, so cost multiplied by 1.8. That will give us the selling price. So we simply have to divide. Remember the two costs from the previous requirements. So those two costs here, P's cost was $50,500 multiplied by 1.8. That will give you the total selling price of the job. Q's cost was $30,800 times 1.8. That will give you Q's selling price. And then if you want the individual unit selling prices, you can do that. Simply divide this by 20 and this by 30, because we are doing 20 units of P and 30 units of Q. So we divided, see, 90,900 by 20. That's our unit price for P, and then 55,440, which is this number, we divide by 30. So that gives us the selling price for Q. Can you see? Alternatively, I find it's much more useful if you know the unit costs. Instead of dividing, if you just do the unit costs of P multiplied by 1.8, that will give you the selling price, and unit cost of Q multiplied by 1.8 will give you the selling price of Q. So that's the alternative. Please see carefully. Okay. Now, requirements 9 down to 15, they're based on a single plant-wide overhead rate, predetermined plant-wide overhead rate, we call. So remember, so far we had two departments, molding department and fabrication department, and we calculated the overhead rates, individual overhead rates of both the departments. One was $5.40, another was $12.20. But now we're going to combine the two and use a single plant-wide rate. Single plant-wide rate is simply add the total overhead cost of the two departments, molding and fabrication, and divide it by the total number of hours of the two departments. The two departments together, the total number of hours was 4,000. So we know the total cost is going to be divided by that 4,000. So let's see what's going on here. Requirement 9, cost of goods sold for the month. Well, I'll get to the plant-wide here in 10, but cost of goods sold is simply the cost of P and cost of Q. This is the easiest. Cost of P plus cost of Q is the cost of goods sold of the two departments. Okay, now come to the plant-wide predetermined overhead rate, which is expected total manufacturing cost, manufacturing overhead, sorry, not manufacturing cost, estimated total manufacturing overhead divided by estimated total machine hours. So total manufacturing overhead was 13.5 plus 18.3. Remember those were in one of the early requirements. And we divided by 4,000. 4,000, one was 2,500 and the other was 1,500 hours. So if we divide it by the 4,000, we'd get the plant-wide overhead rate. Plant-wide rate is going to be $7, I think, 95, $7.95. Requirement 9 was the cost of goods sold, which is simply the two costs of the two jobs together, cost of P plus cost of Q. And requirement 10 is looking for a single plant-wide rate. So simply divide the total amount here, total overhead divided by total hours. All right, so that's number 10. Number 11 is manufacturing overhead applied to projects P and Q, jobs P and Q. So this time P's hours plus times that's 7.95. Remember, now we don't have two rates. We used to have two overhead rates. One was $4.20 and that was one was I think $4 something 65 and that was $12.20. But this time we have one rate, a single rate, which is $7.95. So $7.95 times 2,500 hours, 2,300 hours has gone into job P, and of course 1,700 hours because total hours are going to be 4,000 went to job Q. Remember the numbers 25 and 15, they are from the two departments, molding and fabrication. Molding department had 2,500 hours, fabrication had 15. So that's one collection, one combination of 4,000. But once that those hours have been assigned, have been dedicated to the two projects or two jobs, P and Q, then the hours, our combination doesn't have to be the same because both departments contribute to both the jobs. So P consumed a total of 2,300 hours and Q consumed 1,700 hours. So multiply those 2 hours by $7.95 and you get the overhead applied to the two projects. Now the unit cost of the P products and Q products, unit cost is simple. Total cost of the project of the job divided by number of units. So total cost is, see, P is material labor, same material labor, but new overhead. This overhead amount has changed because we are using a predetermined, a plant-wide, not departmental overhead rates. We are using a plant-wide, like a common single overhead rate, $7.95. So that's the new thing here. Material and labor are the same, old ones, material labor. Overhead has changed. That's why the total cost of the two jobs have also changed. And now divided by 20 and 30, you get the unit costs. During the unit selling price, you simply multiply those by 1.8 because they have markups of 80%. So that's requirement 14, talking about the selling prices. Total selling price for jobs, you can go by jobs. So that's the job cost multiplied by 1.8, job cost of Q multiplied by 1.8. You get the two selling price of the two jobs, then divided by 20 and 30 respectively. 20 because there were 20 units and 30 units here. So that's their individual selling prices. But I find, and the alternative way much better, you simply multiply the individual costs, unit cost by 1.8 because you are having an 80% markup. Well, and the final one is cost of goods sold. Cost assigned to P and Q. Cost assigned to P is $52,000 and Q is $29,000. But you know the costs? These are the two costs from previous requirement from 13. So just remember this number, $81,300, cost of goods sold for the month for the two projects together. Now let me show you something. Look at this. Look at this. What do you see as the cost of goods sold? What is the total cost of goods sold? Sorry, here, cost of goods sold for the month, the whole business, 81,300, isn't it? So the answer to requirement 9 is cost of goods sold 81,300. The answer to requirement 15 is also 81,300, but see this. The two 81,300s what I wanted to show you is that whatever way you calculate, you allocate your overhead, the total cost has no escape. No escaping. So total manufacturing cost of P was 50,500 and 30,008. The two together was 81,003. But here the total manufacturing cost has changed. 52. So 50,000 became 52. 30,000 became 29. But the total is still $81,300. Cost of goods sold under the two requirements. So when you solve it at home, please follow this video. I hope it's been helpful. But the central idea is that job costing is fun. Job costing is easy because it's very identifiable how much material and labor go into a particular job. What is the most challenging, or the more challenging, is how much overhead I have to assign to the particular job. And that's why we have to find out a way. And the way that management accountants have so far discovered is that you either have a plant-wide rate or you have several departmental rates. And then find out how much of which department contributes at what rate to that particular job. And then apply those those rates, multiply them by the number of hours, and then add it to the material and labor. And that's how you have the total job cost. So I hope that's helpful. Thank you for your attention. Enjoy your day. Bye-bye.